welcome to a new video on Blender 2.8 Intel Denoiser. So this year in Blender is quite improving, and they have this denoiser. So with Blender 2.81 that will be coming soon in November, we have Intel Denoiser, which I found more better than the traditional Blender denoiser. So let's go and check. Let's check this denoiser. So I'm in Blender site. So Blender 2.81 is not yet out. It's just it's still in experimental development. So if we go into blender.org, sorry, we could always see the Blender 2.8, which is the final the latest version of Blender. 2.8 is the latest version of Blender. You can see it here, 2.80. so if you download 2.80, you will not have the Intel denoiser. You will only have the traditional Blender denoiser in there. So we are in this video we are going to talk about this Intel denoiser, the cons and the pro of this Blender of this Intel denoiser. So instead of we downloading Blender 2.8, we are going to download Blender 2.81, the experimental version, which is the alpha version now. So go into download here, download, and so we have it here, Blender 2.8, which is not what we want. Scroll down and you'll see get Blender experimental. So it's saying Blender involves every day. Experimental build have the latest features that will, and while there might be a cool bug fix too, they are unstable and can mess up your file, and it's absolutely not recommended to use this on production environments, which is great powerful. So click get Blender experimental. But actually, since I've been using Blender 2.81, I've not seen any sort of fault, maybe some bugs I've never seen. I'm still using it. So this is Blender 2.81 alpha version. It's not yet out still, so you can download the alpha version from here. If you are using Windows, download. On Mac, you click here. On Linux, you just download it. And when you click on download, the download will start automatically. And now we finished downloading our Blender 2.81, which is experimental version. So let's go back into, let's check the release note. So in Blender 2.8 we have new sculpt tools, poly build tools, voxel remesh and quad remesh. We also have transform and snapping, transform origins. We can transform origins, the new snapping, mirroring and auto merge options. In cycles we have new updates. So all these updates are in Blender 2.81. New shaders for texturing, denoising and open image denoiser, and NVIDIA RTX support. In EV also we have shadows, transparency and bumps mapping redesigned for easy setup and better quality in Blender 2.81. And in the viewport we also have some updates, which the new option for look development with cycle and EV. We also have updates for libraries, a new system to replace process to make local override to linked characters and other data type. The rigging also have final control over rotations and scale in bones, constraint and drivers. User interface outliner improvements, new file browser and path rename, and etc. So we have all these updates which are in Blender 2.81. and we also have the denoiser. Also, if you check through that, you find the denoiser, about the denoiser stuff. So now let's go into our download folder. Sorry, our download folder where you downloaded the Blender 2.8.1, and yeah, so open it, extract it, extract that. So when you extract it, you have the folder just like so let's go through it. Download. Let me change the type of this to zip file, so I'll be able to get it, because I have many compressed zip file here. So compressed zip file. So check. So I'm having my Blender 2.81 here. So right click and extract all. So then give the path where you want, the directory where you want to extract the Blender 2.81 package into. So I'm still leaving it at the default place, which is a folder called Blender 2.81 Windows 64. So let's click on extract. So after you extract, it will show you the folder which will be here, which will still be in your download if you left it default, if you left the extract path default. So this is our Blender 2.81. Open it and let's go down to Blender 2.8. you find it here. So because it's not the final version, just an alpha version, that's why it's not coming with an installer for Windows. So here we have our Blender 2.8. So now what we need to do now is that back, and we have some new interface here. New interface. You can see it's not the same interface. It is just a little bit different from the interface we see in Blender 2.8, because all these options here were at the top here, something like that. So now what we need to do now, because we are not going to work with this scene here, we are just not going to work with this. We just want to show the Intel Denoiser. So go back to click on rendering, and now we are not going to be using this render results, okay, but we are going to be using I've rendered something already, a scene for this particular video, for this particular tutorial. I've created some 3 scene for this particular tutorial, so we are not going to recreating a scene again. So I'm just going to bring them into our Blender 2.8. So here the first scene we are going to be using this a room. Let me open it here. So this a room here. We're having a room I just created, just casually created for this tutorial, and you can see this room is not denoised. I'm going to explain there. So let me drag this into. So if you need this scene here, you can comment, or I'll put them in the description below, or you can comment. I will send them to you directly. Okay, so now we have on denoised room. So this a room I created for this purpose, for the tutorial, and now we can see we have this room, but it's not denoised. You can see we have some grainy patches, some grainy stuff on our image here. You can see if I zoom it, you can see how it's looking very grainy. And now, so that's what we call noise in our render, which makes our rendering not very pleasing to the eyes. So now what we need to do now is that we are going to be comparing the Blender Denoiser, which is the traditional Blender Denoiser we use every day, and the Blender 2.81, the denoiser that come with Blender 2.8, which is the Intel Denoiser. Okay, so now I've already denoised this image with Blender 2.81. Yeah, I'm coming. Let me just set this thing to right of view. And so with Blender traditional denoiser, I denoise this scene right here. Don't worry about this white uncompleted image you're seeing here. So you can see through this now. This is so let me import this into Blender. So I'm going to explain that, and now we have it here. So you can see it now. I name it denoised with Blender denoiser here. So which is the traditional Blender denoiser. And so if we go back to the first image, which is on denoised room, so we have some grainy view here. So this actual image is very noisy, and so when I use the traditional Blender denoiser to denoise this, okay, we have a clean image now, but we have a clean image. We can't see the grainy part of our image anymore. But there's also one thing that we need to take care of. If we look at our image very clearly, look at the walls, you can see some patches, some sort of patches. You can see, if you can see very well, we have some sort of patches, just like cleaning the gray by just plastering them on the walls, something like that. Just you can see through it. So the way Blender 2.8 Blender traditional denoiser works is that it renders the image, and then in a second pass use just like something like a patcher, and just smooth out the denoising, the noise in the image, which is quite good, but it gives us some other artifacts that we don't actually need. Like when you see, you can see some patches, some little dot patches on the wall, so which is not good for our scene. And actually, let's talk about the cons of this Blender and traditional. Look at how this scene is lighted in this. After denoising, look at how it is lighted. And if we go back to the on denoise, you can see that in here the light are more sharper than when we denoised it. So when we denoised it, you can't see really the difference, but I can guess the difference. So but the light is almost the same thing. If you don't care about it, you will not even know. And now, so let's use our new Intel denoiser. So to denoise the image by going to on denoise room here. So this is what we are going to be denoising with the Intel denoiser. Going to compositing, and instead of click on use node. So after clicking on compositing, and click on use node, make sure it's checked. And we are not going to be using this render layer here, which is in render layer. We are not going to be using that. So because if we use this, what we are going to be rendering is actually this stuff here, which is not what we are going for. So going to the compositing, and click on this particular, make sure this is only selected, and click on delete. So when we deleted our, sorry, let me just control Z here. Okay, you can just right click and delete, click on delete. And now we can add something else again. Let's add an image. Go to input image here and place it anywhere here, and let's add a viewer which will allow us to view whatever we are editing in this particular viewport. You understand? So if we connect this, so we don't have any image. So which image are we going to denoise? The image that has noise, which is on denoise room. So when we choose on denoise room and we connect the output to the viewer, so we can see we have a room that is undenoised. Okay, so now what we need to do, this room is not denoised, actually it's not denoised. And so now if we want to denoise this, let's use the denoiser, type denoiser. And so this is what we are going to be using, so put it at the end of this. And let me just cancel that. Okay, now let me move this up and down, let me bring it down. And now we have the denoiser. So the denoiser is having something like image, which is the output, and image also, which is the input, which is the undenoised image we are going to put here. And we have also normal, we have normal, vector, and we have albedo. So these two, like whenever you render, whenever you render in 2.8 you need to, I'm going to explain that later. So but let's focus on our actual image here. So now connect this image here, output to this image here, which is the denoised image. Okay, undenoised image. So when you connect this undenoised image to this, actually what Blender would do for us is that this denoiser will not denoise our image for us, and when it denoises it, it's going to send it to the compositor, composite, which is the final composite, or the viewer. So let's connect it to the viewer, so we'll be able to see what we are doing in real time. And let's wait for it just a couple of seconds. You can see here compositing is saying compositing, because after we connected the output of this denoise, which is the Intel denoiser, this is the actual Intel denoiser here, to the viewer. So this grainy image will change after the compositing is done, remaining a little seconds to get done. So this image will change. Just look at the grainy image, and so in few seconds we have this here. So we can see here in the viewer we have our denoised image, very clear, and we could see, like when we look at coming. So let's connect this to the composite, which is the final composite. So drag another output from here and click on it again. So we are going to wait for it to composite this again. So let's wait a few seconds. So we have here, so now if we go back to our rendering here, and so this is our undenoised image, here. So if we go into our viewer node here, and we could see that our image is very clean with the Intel denoiser. We don't have any patches on the wall or any other stuff and that comes. So now if we go into our actual denoised with Blender denoiser here, we can see that we have patches here. So which we can see that we have many patches on the wall, which is fake denoised. And in the viewer node we have a highly denoised image. So we can see we don't have any grainy, any noise in our render. It's very clean. You can see, you can look at the wall from here. Now you can look at the wall, how the wall is not even, there's no any patches on the wall. But let's go into the denoise with Blender denoiser, so we can see we have patches on the wall. If you can see very well, we have some patches on the wall, which is very fake, denoised fakely. So if you go into the viewer node, which is the image with denoised, you can see we have some cool. So Blender the Intel denoiser does not only work for renders, it works for any type of image you've already rendered, or any any sort of render that you have done before, you can use them in the with the Intel Denoiser and denoise them. Like any other image you have that is having noise, you cannot bring them into Intel Denoiser and it will denoise any type of. So you can denoise your render, your while rendering, and you can denoise your image just for you. So which we have. So the advantage using Intel Denoiser is that first thing, it is not denoised in a high resolution. Two, you can never find any patches with Intel Denoiser, which is unlikely to Blender traditional denoiser. Thirdly, the image and the resolution, the image doesn't get blurred or something like that. And so we have here, you can check, like on the noise room we have this noisy, you can see the noise in our room like this. So if we go into our denoise with Blender Denoiser, you can see we have patches on the wall. You can actually see these patches on the wall, yeah. And in the viewer node, which is the denoised image, we could also, to make sure this image is showing in the render results, we could re-render this image by just clicking render image. And what it will do for us is that it's going, instead of we using this viewer node in the viewer node to view our image, we'll now use the render results by just going to composite thing, because we have already click on use node. So if you click on render image here, it's going to render this particular stuff we did here out into our render results. So now we have seen the advantage of the Intel Denoiser. So let's check if we can see any bug or any fault in the Intel Denoiser. So let's go into our actual on the noise room. So let's look at the light, everything, the way everything was lighted in the room, in the scene, in this particular scene. Look at how the light is sharper on the floor textures, on the chair, on the chair corners of the chairs, the table. Look at the details on the table. Look at how the light travel, how far the light travels in the room, so we can see clearly. And when we check in the Intel Denoiser, let's see if those details are gone. So the Intel Denoiser, which is the view node here, we could see that the chairs is still having the same details, the same light, the same how far the light travels, and the reflection, the same reflection on the texture, the floor texture, which is great. So, but actually I found something that the Intel Denoiser did, which is a faulty way of doing. So there's also, because Intel Denoiser has a big advantage, but we still have a little bit cons. So if we go into let me import something like this. This also is a watercolor rendered in cycles, and if I zoom it very clearly, you can see we have some noise here in the image. You can see on the here we have noise. If you can see like me, you can see we have noise around, noise everywhere. So what we need to do now is that let's go into render results and import this actual here. So now we have this in our screen here. No, sorry, in our come on. So now this is an undenoised stuff. Let me just make it as that we get, let me rename it, we get it very clearly. Undenoised. Okay, so this is actually just a sketch I did for this particular tutorial. And so when I used the denoiser, actually the Intel denoiser, we can see, okay, now this is undenoised, this is undenoised, but we could barely see the noise in this render because of the light shining, reflecting in our eyes. If we look closer down here, we could, when we look at this side, we can see the noisy part of our image. We can see the noise zoom, we can see the noise. So let's denoise this with Blender, the Intel denoiser, sorry. So instead of we choosing this image, let's go and choose the image we import now, which is undenoised. So because we have set this, we have set all this actually done here by us, after we set the image, now we are going to be denoising this actual image here. And let's wait for it to composite, and to the compositor to finish. And when you finish, we can go to our, so let's wait for it. So after this the composition is done, we can see in the viewer, actually when we are looking, let's go into our rendering and go into the viewer. So the viewer will change because we render another image in the viewer. And if we look here now, we could see that when we zoom in, we don't actually have the noise here. So the noise are gone because the Intel denoiser is super awesome to clean every noise in our render. So we don't have any noise here, but there is something I found wrong with this. So with this particular scene, what I did is that I used an HDR to light this scene. I use the HDR lamps. You can see it at the back here, at this side here, and this side here, and I think one at the back of the camera to light the scene. So those are HDR lightning. And in the denoised room, what I use an HDR outside, which is wrong because it's an interior. Why will you use an HDR to light an interior? But it was not for lighting the interior, but I use it for other purpose. But the light source of this interior scene is an area lamp light. So now if we go back to this viewer node, which is denoised, we could see that the lights are dimmed now. So let's go back to the undenoised part. You can see that the light is reflecting at this background, this aluminum background. The light is highly reflecting on the floor. The light is highly reflective on the floor texture. You could see that the light is very reflective, and at this part also very reflective everywhere. You could see that the light shining through the image. But now we have a clear but this is on the undenoised image here. You could see that, but the lights are very sharp and the reflection are very sharp. But if we go into our denoised, this actual denoised image here, view node, which is in the view node, we could see that every light were dimmed, or the reflection went down. The light, the sharper light went down. Everything became like if the light was having 100%, we are now having 50% or 60% light in our scene, because now we can see this image is much more darker than the undenoised image. You can see we have more reflection here and more reflection down here, very reflective. The light coming from the HDR are much brighter, so making this image, this scene, much more brighter. But when we denoised it with the Intel Denoiser, we found that even the HDR are not even lighting more like that, and the light coming from them is not strengthening enough, and the reflection also is not okay. Light is not shining, it's not very sharp, which makes the image more darker. So what I concluded is that it's like this Intel Denoiser is actually not okay when you are using an HDR to light a scene, and you denoise that image, it denoise that render. The Intel Denoiser like bring down this HDR light, which makes it very so because when I used a traditional lamp, sorry, what do we call it, an area lamp to light this scene, to light the room. When I denoise this scene here, it's actually the same reflection, the same reflection, the same, like when we look down here we have some reflectivity from the chair to the floor. You can see there from some reflectivity from the table to the floor. So the lights, the windows reflecting, everything reflecting, the light was very sharp. Okay, and when we denoised this image, actually with when we denoised the image, it was still the same sharp light. So but when I use an HDR here in this picture, and then we denoised it with the Intel Denoiser, the light goes off. Every light was now darker than the way it's supposed to be. So it's like if you are using Intel Denoiser, it's better to use a light source that is coming, a light coming from a lamp, instead of you using an HDR. Or when you are using an HDR, you need to brighten up that scene much more than this, so the reflectivity will be much more higher than this one. And so when you denoise it, it will not look like this, but it will still almost like this, same thing. But if you're using a lamp, a traditional lamp, which is area lamp, sun lamp, any lamp, I think it will still have the same resolution, the same quality, because I used an area lamp here, so when I denoise it, it's still having the same details. So these are the cons of the Intel Denoiser. It's like it doesn't really work well with HDR lights. So another tip I'm going to give you is that whenever you are creating an interior like this, this one here, don't use HDR to light this in. You can use HDR for the exterior thing, okay, but don't use it to. And another come on, so let's see another scene here that I created, which is this cycle noise room home. Click. So you can see actually in this render we have some bright light, sharp light, but this render is noisy. You can see so much of noise here, much of noise. And what I did here is that I used an HDR for the outside, for the exterior, and this lamp here you're seeing here, I use a an emission shader to emit light, and I use a traditional point spotlight to mimic a light, like a round light, a circle light on the so we can see on the sofa we have some bright light, some sharp lights on the sofa. On the ground here have sharper lights. We have a sun lamp pointing down into the room. Here we can see some sunlight pointing out like this, so I put a sunlight lamp at the exterior at this side pointing here. So if we denoise the image now, we could see also something that happened. So let's just look at the sofa, the edge of the sofa here. We can see the sharper the light is at this edge here. So if we denoise it now, you could see that let's see something. Go back to the compositing and let's change our image. So if we choose this cycle home noise now, so let's denoise this and see how it looks like. So we after because we have this setup done, it's been denoised. If we're going to our render, we're going to so this is the undenoised image. We could see on the sofa we have some bright lights on the sofa here. So if we go into the denoised image, which is the view node, we could also see that we have the light reflective, but we don't have much more, and the light is not sharper in the same way. It is like when we look here, you can see that the light is sharper on the sofa. When we look at this side also, it's very sharp, just very sharp here. And but if we go into the viewer node, which is the denoised image, we could see that we have a clean image without any noise, very clean, but the light are so sharp the same way, but a little bit minus from the actual noisy image. So but without anybody thinking about that or looking for any means of fault from the Intel denoiser, or looking at the noisy image and the denoised image, there will be no difference in them. So if you go into the view node, you could barely see the difference between this image and the noisy image. So the reflection on the floor are quite the same thing, very 100% the same thing. Everything are 100% the same whenever you denoise the image with Intel denoiser, but it's only having when the light is sharper, like when the light is having 99% sharp, well, let me say 100% sharp. When you denoise it decrease by 1% or 0.1%, sorry, which is 99%. So actually I recommend the Intel denoisers.